production-ready assets in multiple formats, so single VMs, multi-DLs, and I was focused on containers and Helm charts. And recently I moved to another team inside Bitnami. I'm now part of the Tansu application catalog team, but I still remember all the things about Helm charts. So let me share my screen and the presentation. Yeah, here it is. So I already introduced myself, so I'm going to skip this slide. This is where you can find me in GitHub and on Pizarro, also on LinkedIn or in the Kubernetes Slack. And I'm here to talk about distributed repositories. What is this? Distributed repositories was the original idea when Helm was designed. Since the very beginning, Helm was designed to work with these distributed repositories. And we know this because the command line interface of Helm, it has several options to work with repositories. You can add them, you can list them, you can remove them. But by default, until the Helm version 3, there was one repository added by default, and this one was the stable repository. So as long as you download the Helm command line, so one moment. Yeah, now. So as long as you install the Helm command line interface, you are already able to install each chart that was already available in the stable repository without any need to add a new repository. This made people think that the stable repository was the only way to install chart and the only way where we can discover chart, but this is not true. This stable repository was only created to kickstart charts, so users were able to quickly deploy charts without any other configurations. So with the version 3 of Helm, this repository was deleted by the default list, and now you need to add one repository by default. This stable repository will be deprecated, will be marked as obsolete on 13th of November of this year, and it was marked as deprecated the past 13th of November. So during this time, if you have tried to publish a new Helm chart there, you will have received a notification by one of the maintainers saying that the repository will be not used in the future, and you better publish your Helm chart to another place. So as I said before, in Bitnami we have a lot of experience with Helm charts, but we have a catalog of more than 70 in the Bitnami charts GitHub repository, and we thought it would be beneficial for the community to share our experience with that. So I'm going to talk about the maintenance process that we follow here in Bitnami and what are the main points that are important in this process. So the first one, in order to maintain a chart repository, you need a place to store these charts. We will see later that there are different options. You need to test all your charts before publishing, as you need to guarantee that they work properly, so your user doesn't find any unexpected issues when they are trying to deploy them. You need to maintain the charts. It's not that you create a Helm chart, you publish to a GitHub repository, and you forget about it. Your Helm chart contains Docker images that needs to be updated. There are new defaults in the industry that you need to be applying. You need to add new features, fix bugs, and that stuff. And finally, you need to maybe not publish directly. No, maybe publish is not the best word here, but you need to make the charts available for the community so it is easy to consume them. It is easy to install them and to discover them. So starting with the first point, how to store your charts. A chart repository is really simple to create. There are a lot of options already created for that. And you just need, let's say, a web server that is able to serve a YAML file, which will be the index file of your repository with all the versions that are already published there. And it should also serve gzip tarbats, the chart itself. There are plenty of options here. There are GitHub pages, AWS buckets, JFrog, Artifactory, or you can use regular or web servers like Apache or Nginx and just maintain the htdocs folder yourself. There are also other interesting options like Chart Harbor or Chart Museum. As with this project, you can self-host your charts on your own infrastructure in case you want to have full control of your charts. So I'm going to stop some seconds to talk about some great features of Harbor, as it's a project I like a lot. Apart from being a chart repository, it's also a Docker image registry. So with just one tool, one project, you can have a Docker image registry and a chart repository. So your charts consumes the Docker images from that same registry. And some additional features over this Docker image registry is that the images can be synced with Notary, and they are even analyzed for security vulnerabilities using engines like Flare or Trivy. And finally, with the Harbor 2.0 version, is the first OCI compliant open source registry, which makes this tool to have a great future. So that was all regarding how to store your charts. Let's move to a very important point, which is which kind of test you need to do to your charts and how far can you go with them. The first test that you can think, or some quick test that you can do while you are developing a chart or while you are adding a new feature or doing a small change, is running the Helm template command. So with Helm template, you will be rendering all the YAML files. And for example, it will be useful in case that you have forgot to close a curly brace or some kind of these syntax issues. You will be able to quickly spot them. The same will be achieved with the Helm install, passing the dry run option. But the next kind of test or the next kind of validation that you can run to validate your charts is the Helm lint. There is a project, the chart testing project, which is a linter and tester project that it has been used for a lot of time in the stable repository. We use the linter to check that the version of the bump has been bumped in any new pull request. As chart should be immutable. As soon as you change a small bit inside the chart, you need to create a new version of the chart. So this linter ensures that the chart version is updated in each pull request. And it's also runs some YAML schema validations and YAML linting on the chart YAML and values.yaml. So this gives you another test that you can run apart from the template. But just running template, dry run, a linter, this doesn't really guarantee that the Helm chart is going to be properly deployed. So at the end, if you want to really test the chart, you need to install it on a Kubernetes cluster and check that all the pods are running, the volumes are attached, the config maps are also properly mounted to the pod. You need to check that all this deployment finished successfully. But Helm charts are really configurable. And you may have one chart that can be deployed with different, using different values.yaml or with different properties, and this result in different environments. So for example, the MongoDB Helm chart can be deployed just as a standalone server, or if you tweak the values.yaml, you can deploy a full MongoDB replica set environment. So you may also want to test these different scenarios for a same chart. Another example can be WordPress chart. You may be interested on testing with different Kubernetes services using a load balancer an ingress, cluster IP, or node port, you may want to test these different configurations, or you can decide if you want to deploy a chart with persistent or without persistent. So with all these, after we have installed the Helm chart and we see that the pods are running, the secrets exist, and everything looks that is working fine, you need also to test that the application that you have deployed is working fine, because it can be that you have deployed a MongoDB replica set, but really the configuration is not properly done, and you have deployed several standalone MongoDB services. So you need to, at the end, you also need to test the application to check that the configuration has been properly configured. So at Bitnami, we has this kind of test, verification and functional are the two kinds of tests that we run. For verifications, some examples are checking that important file exists, that permissions are properly configured, that some binaries doesn't have any missing library, or testing the application itself. And for functional testing, it's mainly for web applications, and it's just a simulation, what a user will do if they navigate through the web page. So they click buttons, they select options, they create user, upload images, all this kind of stuff that you can do with web applications. So for example, here, this is the output of one of these verification tests that we run on our Bitnami pipeline, or release pipeline. And this is an example of the MySQL chart. We have some common tests that we execute on all charts, like checking that any binary has not found libraries. And we have other specific to each of the chart that we want to test. So for example, as this case is MySQL, we are testing that we can create a database, we can create tables, we can insert data, we can delete it, and we check that the application works properly. This is just a basic test, but for example, if you want to test MariaDB replication, you can create this data in one of the pods, and you can go to another pod and check that the data exists. You just need to, add the tests that you think are important for your use case. With regards to functional test, this is the output of a test for the WordPress chart. Here in this test, we are simulating that a user log into WordPress, go to the new post section, and create a new post with the title testing post 1, and he publishes it. So we can see this during the log. During this process, we also take screenshots. So in case there is any error, we can quickly debug or see which step is the one that fails. So, for example, the first part of the test will be just go to the WordPress login page, input our user and password. We reach the main WordPress dashboard. We will click on the Add a New Post button. We insert the title and the body, and finally we click on Publish, and we see the post is published. So with this verification and functional test, we have checked that the application works properly. But now another guarantee that we want to give to our users is that Helm upgrades works. So we want to guarantee that the upgradability works between major versions. So we also test upgrades in our pipeline. So the process that we do in this case is, imagine I want to release a new version of the WordPress chart, let's say the version 7.1.1. So I will first install the base chart where I'm going to upgrade from. in this case, it will be the minimal version inside that same major version. In this case, it was the major version 7. So I will install WordPress 7.0.0. I will run all the tests that I commented before. I will check that the MySQL works, that WordPress works properly, that I can add users. I will add some images at the end. I'm going to populate some data. I'm going to insert some data in this chat so that later I'm going to upgrade to the version that I want to release, this 7.1.1 I commented before. So I run this Helm upgrade command. And finally, I run the test against this new Helm version. And I check that all this data that I inserted before is still there. So for this, we use the same tool that for running our functional test. So we have some scripts to populate the data and to check that the data is still there after an upgrade. Another tip with regards to testing is deploy your Helm charts to several clusters, because we have seen that even there are a lot of Kubernetes flavors. Each cloud provider has their own Kubernetes services. And we have tested Helm charts in basically all of them, I would say. And we have detected that one Helm chart that works properly in one Kubernetes service is not working properly in another. Mainly because there are some differences between this Kubernetes version, or some small differences. So, for example, we detected that changing permissions on Azure Kubernetes service was really slow with the default volumes assigned to a pod. And we had some applications with a huge amount of files. And if we had to change the permissions for these files during initialization time, we found that it was super slow. So slow that the proper liveness proof of Kubernetes was killing the pod, as it was not ready in a reasonable amount of time. The second thing that we have detected at Bitnami was that the IBM Kubernetes service didn't fully support the security context Kubernetes feature. One of the things that security contexts are for is to select the owner of the volume that you are going to mount to a pod. So if your pod is running as non-root, you need the volume to be owned by that user so you can write things in that volume. And we detected that this was not working by default, and we need to think on a workaround. Finally, there are also another Kubernetes platforms that runs all the containers, all the pods by non-root. So your chart should be prepared for this, or you may have a lot of permission issues here and there. The third point on our maintenance process is maintain the chart itself. So as I mentioned before, you cannot just publish a chart once and forget about it. You need to update the Docker image that are used by that Helm chart, just basically to get CVEs fixed. Also, maybe new image includes new features. It fixes bugs, and you may add new features also to the Helm chart thanks to the new Docker images. And also, it's really important to listen to your users, to your community. So at Bitnami, we have internally we use a Trello board where we collect all the issues and pull requests from our Helm from GitHub Bitnami chat repository, and we try to reply to all of them within a business day. We try to reproduce the issues. We accept pull requests that users may submit. We contact users in case that we are not able to reproduce issues or we need more information. So this is also another way to improve your Helm charts. As I commented, there are a lot of environments, and it's practically impossible to test all the combinations of inputs, all the clusters available. So your users are a good way to detect these issues. Some other tips in order to develop charts. Avoid using mutable or rolling tags for the Docker image. As I commented before, the charts are supposed to be mutable. So your chart won't be mutable if one of those Docker images used by the chart are mutable. Document every major change in the README. This will help users to upgrade from one major version to another, because usually some manual actions are required in order to upgrade to a new major version. Also, I found really useful to document how to access the application that you deploy on Kubernetes using the different kind of services. Even if you cannot access your application using one specific version, using one specific service because of whatever reason, it's fine to document it so users don't try to deploy something that is not going to work. Another thing, validate users' input as much as you can. For example, if you know that a cluster version of an application doesn't work with more than 5 replicas, don't let users to deploy the charts with more than these 5 replicas. So you can do this with helper functions. And also, if you plan to maintain a whole catalog of Helm charts, having a checklist is something that will help you to create new Helm charts and to maintain all your Helm charts consistent, in case in the future you need to add batch changes to all of them. And finally, how can you make your charts available to everyone? There are several similar projects that you can use for this. The first one I'm going to comment is the Helm Hub, which is a CNCF project, and it's just a marketplace of charts. Here at the left, you can see that there are a list of repositories. All those repositories has a lot of charts, so you can browse between all of them and see several versions for the same chart from different repositories, and select the one that better fits your needs. This is, if you want to add your own repository there, it's easy. You just need to send a pull request to that URL with the URL of your repository and the name. Also, you need to add your contact information, and they will check that your Helm charts meet some expectations, like they are immutable, they have a maintainer, your notes.txt includes useful information, that. A second project similar to this one is QApps. QApps is a Vietnamese project, and it's similar to the Helm Hub. In his Hub version, there is a hubqapps.com version, which is another marketplace with several repositories where you can browse charts. But the peculiarity of QApps is that it's also an application that you can install on your own cluster, and you can use it to manage your charts deployments from a web UI. So you can deploy charts from there, or you can delete it, upgrade it from a web UI. So some screenshot of QApps, as I said, is some like a marketplace where you can deploy charts. In this case, WordPress. You can see here the notes.txt. You can see that is deployed using a service load balancer, and you can see there the URL where you can see your WordPress application. You can upgrade and delete it. And when you deploy WordPress, you have access to the values.yaml in case that you want to tweak some of these options. Right now, there is also a form, which is much more easier to configure. And there are another great features in QApps, like support for operators. We are working on multi-cluster support. Another option will be using the Artifact Hub, which is a new project by the CNCF Foundation too. And apart from being a marketplace for charts, it's also a marketplace for other CNCF projects, like operators, Falco rules, OPA policies, etc. And right now it's in alpha state, and as QApps, you can install it on your on your cluster too. The last of this kind of marketplace is the JFrog Chart Center. The peculiarity with regards to the others is that it analyzes your Helm charts, your dependencies, and it runs a vulnerability scanning over the dependencies and the Docker images used. So this is a nice feature of this marketplace. And finally, another option, if you want to publish your charts and make them available to everyone, is use the cloud providers marketplaces. So for example, Azure has a marketplace, as well as VMware has another marketplace for containers and Helm charts. So to wrap up, these were the 4 main points: store, test, maintain, and publish. Store, be aware that there are different choices. So so select the one that better fits your need. For test as much as you can in several Kubernetes platforms. Maintain, just invest time maintaining the Docker images and listen to your community. And publish, just check which of these options most likes you and submit your repository there so it's available for the community. So thank you all. I hope you have found this presentation useful.
Thanks so much, Tomas. So I'm a huge fan of the Bitnami Helm charts. And I'm also really excited to see just how important testing and releasing charts is to the Helm charts community. So thank you so much for taking us through it all. And I hope people get a chance to dig into Helm charts more. And we'll be back in just a few moments with Yuri.